Okay, so I'm looking at MyiMaths linear programming. Question 1, pet holidays. A holiday home for pets has separate accommodation for rabbits and cats. Write each of the following conditions as an inequality. Okay, the maximum number of rabbits is 15. Okay, so you have to have 15 or fewer rabbits. So rabbits has to be less than or equal to 15. So it can be up to 15, but no more than 15. The maximum number of cats is 23. So C is cats. C has to be less than or equal to 23. The total number of pets cannot be more than 28. So in other words, it has to be less than or equal to 28. So rabbits plus cats, that's the total number of animals, because there are no other animals in this, cannot be more than 28, so it has to be less than or equal to 28. And the company needs to take in at least $240 per day in charges. So they charge $10 per day for a rabbit and 15 for a cat. So the amount they get for rabbits is 10R, 10 times the number of rabbits, $10 for each rabbit. And then the number that they get, or the amount that they get for cats, is 15C, 15 times the number of cats, $15 for each cat. So the total money they get in charges is 10R plus 15C, and that has to be at least 240. So it has to be greater than or equal to 240. So I'll type greater than or equal to 240 and I'll mark it. And there we are, 7 out of 7. Okay, so we're doing linear programming. Question 2 from MyiMaths. A bookseller sells P paperback books and H hardback books per week. The total number of books sold is at most 450 per week. The number of paperbacks sold is at least twice the number of hardbacks sold. The paperbacks sell for $5 each. The hardbacks sell for $12 each. Write an inequality for the total number of books sold. So the total number of books sold is at most 450 per week. So P plus H is less than or equal to 450. Seems like a bit of a silly question, because why would you limit the number of books you sell to under 450? So it's not like a constraint that they'd want to be complying with, but that's what the question says. Write a second inequality from the information given. So the number of paperbacks sold is at least twice the number of hardbacks sold. Okay, so the number of paperbacks, so it's not equal to, but it's at least, so it's more than or equal to, so greater than or equal to 2 times the number of hardbacks sold, so 2H. The number of paperbacks is more than or equal to 2 times the number of hardbacks. And then it says to draw a line, drag the circles to its endpoints on the grid, enter alpha. Okay, that's, we don't need to worry about the L and the G, we've done that. Click the region satisfying both inequalities. Okay, so I'm going to try and make a line that represents the inequality P plus H less than or equal to 450. Okay, well, I'm going to think about P plus H being equal to 450. So if P plus H equals 450, let's say P was 0, then H would have to be 450. So that would be down there, wouldn't it? If P was 0 and H was 450, then we'd be at that point there. Or the other way around, if H was 0 and P was 450, then we'd be up there. So I've drawn the line where P plus H equals 450. And then my second inequality is P greater than or equal to 2H. So I'm going to try and draw the line P equals 2H. So if H was 100, P would be 2 times 100. If H was 200, P would be 2 times 200, 400, and so on. So that's the line P equals 2H. Now everywhere above that line, P is greater than 2H. And everywhere below this line, P plus H is less than 450. So our region that satisfies both inequalities is this triangle here. So I've just clicked that there, and it's shaded everything off and left me with my region R. Use the graph to find the maximum value of the weekly sales. Well, according to the linear programming theory, the optimal point is going to be a vertex of the feasible region. So either their maximum value of weekly sales is here with no paperbacks and no hardbacks. Well, obviously that makes no sense. Or it's going to be here where they're selling 0 hardbacks and 450 paperbacks. Or it's going to be somewhere down here where these two lines meet and they're selling, well, it looks like 150 hardbacks and 300 paperbacks. Well, let's just think about that. I'm going to go into Desmos. So 100 and let's just go back to get those numbers. Yeah, 150 hardbacks would be $12. So 150 times 12 plus, just get on the right thing there, plus 300 paperbacks at $5 plus 300 times 5. Okay, that would give me sales of $3,300. Whereas if I was up here selling 0 hardbacks but 450 paperbacks, then that would be earning me 450 times 5, $2,250. So actually their optimal outcome is to sell 150 hardbacks at $12 and 300 paperbacks at $5. So that's giving them $3,300. So let's put 3,300 in there and mark it. And there we are, 100%.